folks, this is Stan Forrester. We're working with lesson 7.1, and we're going to be dealing with, we've already done two-step equations, okay? But now we're going to do work with equations with the variable on both sides of the equation. All right, so let's come on down here. And the first example we're given is x plus 5 equals 3x minus 1. Okay, they don't really tell us what the variable stands for or anything like that, but they do ask us to use the algebra tiles. So I went ahead and I put something together for you. I hope this works out. Now remember, this is a review. Algebra tiles, these yellow squares are single units. Okay, so this would just represent the number 1. It's a graphic representation. It's an area representation of the number 1. 3 of these represents 3, and 6 of them represent 6. Negative numbers are represented by red squares. So 1 plus negative 1, well, that would be 0. They kind of cancel each other out. You can think of them as matter and antimatter, and they go poof, they go away. Your unknowns are these green bars. There are these green bars. Now you might be tempted to just try to line up these yellow squares to see how many yellow squares is equal to this green bar, but very purposely we don't make them and enter a whole number of yellow squares, so there is no exact match. Okay, so we're using this here. This is an unknown. Okay, for negative x, we use these red rectangles. Okay, just like that. Okay. Now, so let's go on down here. So we have our x plus 5 equals 3x minus 1. This is our setup. Okay, right here. Okay. So here's our x. We just have a single x plus 5 single units right here. Here we have 3x. So we have 3 of these green bars and 1 negative. This is a negative unit. Okay. And so how do we do this? How are we going to take care of this? How are we going to solve this? Well, let's try to rearrange things so that the variable's all on one side, or the variable term is all on one side, and we'll combine them all into a single variable term. And the constant term is on the other. That's the first step. All right. So let's see what that looks like with these algebra tiles. The first thing I'm going to do is I'm going to add the opposite of this x value right here. Like we have 1x here and 3x here. I'm going to add the opposite, and that happens to be a red bar right there. And so let's look at this. So here's the same problem with the addition of that red rectangle and the red rectangle here. I've drawn a purple rectangle around this to indicate that these are now paired up. This makes what they call a zero pair. So, and that goes away. And so right down here, we can see when these rectangles go away, there's no rectangles left. Over here, when this rectangle and that rectangle go away, this positive x and this negative x go away, we're going to be left with 2 x values, 2 x bars. Okay, so we have 1, 2, 3, 4, 5. That's what's left. There's no x over here. There's 2 x bars and a negative. Well, we have our variables over here, and that'd be great if we could just get rid of that constant. Here's how we do that. We're going to add its opposite. We're going to put a positive unit here. I've drawn a purple rectangle so that we can see that that's a zero pair. But if we do it to one side, we have to do it to the other. All right, so there's it all rearranged. Okay, so we have 6 of these single unit values equals 2 times the x value, or 6 equals 2x. Well, right there. Okay, so all we need to do now, we've already reduced this to the point where we can think about it as a one-step problem. And the best way of thinking about this is that we ended up with 2 x values and these 6 single units, and we're going to just move these apart so that each of them experiences only its own set of, they have equal numbers of its own share of these unit values. All right. And so let's take a look at that. Put the purple box around there to draw. Like I've taken these apart. I've taken this setup and I've drawn these two rectangles apart so we can see that x equals 3. And we're back to our Go Math pages, and we can see that that's exactly what they've done here. A single bar here, positive values, there's a negative value in red, and they have sort of an abbreviated version of this, but in fact they ended up with 2 of the x values equals 6. Now, there's another one, interesting question. How can you check the solution to x plus 5 equals 3x minus 1 using the algebra tiles? And so I've come back here, back to our paint setup. All right, and here's the original problem. Here's x plus 5 equals 3x minus 1. Now, we remembered that x equals 3. That means that this bar here is worth each 3 of these single units. So what if I come down here and I'm just going to replace this, okay? So I'm just going to put it right there. And then I'm going to do the same thing for each of these green bars. Each of those green bars, the same thing as I'm just substituting that in. And then I'm going to take one of these. I'm going to pair that up. I'm going to pair that if I can. Okay, well, I can't do that, so because of the way the recorder is set up. But I'm going to recognize that that's a 0 pair. And I'm going to cut that. And let's see what we've got. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 equals 8. That's a correct statement. And so that's one possible way of using the algebra tiles to check your answer. We're back, and let's move on to the next page. Okay, so this is solving an equation with variables on both sides. Here's our first example. We start with, and I'm not going to work this out because we have plenty of other examples, but Andy's rental car charges $20 plus an additional $30 per day to rent. Buddy's rental car charges $36 plus an additional $28 per day. So I would have set this up a little different. I would have said, how many days, the question is, how many days is the total charge the same? So I just set this up. Buddy's cost equals, what is it, Andy's cost? Buddy's cost equals Andy's cost. And then replaced the cost for Andy's rental car with the initial fee plus the cost per day. So 20 plus 30x. And I would have replaced Buddy's with the initial fee plus the cost for x days, or 36 plus 28x. We end up with this over here. Now, you have a choice at this point on how you're going to rearrange things. And sometimes it pays to think a little bit about this and make a choice that makes your life easier. And if you don't have to deal with negative signs, that makes your life a little easier and possibly even removes a source of error. So let's look at these variable terms here. There's a variable term there and a variable term here. Okay. Notice that this one's larger than that one. And so if I were to try to remove the variable term here from both sides, I basically subtract 28x from both sides. Well, that would leave me with a positive value here, okay? And so the 30 is larger than 28, and we're going to end up with 2x, okay? Instead of ending up with, like, negative 2x, all right? So that's what we've done here. Okay, 20 plus 30x equals 36 plus 28x. That's our equation right here. They've subtracted 28x from both sides. Well, 28x subtract 28x, well, that's as close to like a 0 pair in the algebra tiles as we had. Okay, so that goes away. So there's no longer a variable term on this side. Over here we have 30x minus 28. Well, if you have 30-something and you take away 28 of them, you've got 2 left. Well, we're going to play the exact same game. We're going to play the exact same game with these constant terms. So basically what we're doing is we're collecting similar terms on the same side of the equation. All right, so let's take this, okay, we've had the variable term here. Now let's get it by itself. So we want to get rid of this 20. What's the opposite of adding 20? Well, subtracting 20. So we subtract 20 from both sides. Again, this is what in the algebra tiles they would have called a zero pair. So we have 2x. That comes down here. There's no constant term. 36 minus 20 is 16. 2x equals 16. Now, we have a variable term here, which is a variable times a coefficient. We want to get rid of that coefficient. We want to get rid of the coefficient. So what do we have to divide by to unmultiply by 2? And of course, you already know that. So at 2x divided by 2. Well, 2 divided by 2 is just 1. We don't have to write a 1 down, so that you can always imagine that there's a 1 there and then forget about it. Okay, 16 divided by 2 is 8. X equals 8. Are we done? Yeah, I like to add another little step in, which is you take your proposed solution here, proposed solution x equals 8, and you plug it back in and see if it gives you a true statement. All right. Now you can do that if you want. I'm going to pause this and upload it, and then we'll continue on.